Hello kids, ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲ? Okay, so once after mole concept and law of chemical combinations and all, as we all know, for UG competitive exams like JEE, mains, advanced or NEET or CET or any other concepts, the most important part of this is the percentage composition and limiting reagent. If you just go through any of the PYQs, you'll see many questions on limiting reagent and percentage composition. So we will learn about what is limiting reagent clearly in depth, and also how to check for percentage compositions. So let's get started. When I say limiting reagent, so usually what happens, limiting reagent is a quite confusion with respect to the mass, volume or the capacities. When we talk about real life examples, it looks very easy to understand. But when it comes to a reaction, that is where the difficulty falls, right? But we will see how that difficulty also breaks down. That complex will also be cracked. Okay, so when I say I have around some 10 wheels, okay, 10 wheels of a bicycle and around 4 body parts of a bicycle, 10 wheels and 4 body parts, that means how many bicycles we can create today? 10 wheels and 4 bicycle body. So each body part require 2 cycles, 2 wheels for a bicycle. That means we can only create 4 bicycles. Yes, but we left with 2 more wheels there. Out of 10, we left with 2 more wheels and we utilized only 8 wheels. That means the body of the bicycle, which we had only 4, here acts like a limiting reagent. That means it is being consumed earlier. And the wheels which are extra, those are excess reagent. That means they are left over. Clear? Simple. So let's understand that in a chemistry way. So now I have nitrogen and hydrogen, and together they can form ammonia. Alright. But I have nitrogen always for this particular reaction. When we balance the equation, 1 mole of nitrogen requires 3 moles of hydrogen to create 2 moles of ammonia. Correct? So now just imagine I have some 10 moles of nitrogen and 7 moles of hydrogen. Okay. So now how many moles of ammonia we can create and what is the limiting reagent in this reaction? Okay, think for a while. So now according to the reaction, if you see carefully, we have 10 moles of N2, each mole requires 3 moles of hydrogen. So 10 moles of this means we require 30 moles of hydrogen. And then if we had 30 moles of hydrogen, we can have 20 moles of ammonia. But my dear kiddos, can you please check how much of hydrogen do we have? 7 moles. That means these 7 moles are not enough for 10 moles of nitrogen. So this will be consumed earlier and our limiting reagent is hydrogen. Simple. That's how you have to check which is limiting reagent. Okay, ma'am, that's fine. Now we understood this is the limiting reagent, but can we check with this amount of limiting reagent how much ammonia is possible to be prepared? Yes, definitely it is possible. Let's check how much ammonia we can prepare using this 7 moles of hydrogen and 10 moles of nitrogen. So if you see here, whatever the moles of nitrogen and hydrogen we have, 1 mole of nitrogen is required accordingly with 3 moles of hydrogen. So how can we do with this? According to this particular reaction. Reactions are important. You have to keep that in mind. How can I divide or multiply anything? We can't do it blindly. We have to focus on the reactions and the number of moles involved in the reaction. So here for 3 moles of hydrogen, the number of nitrogen moles required are 3 by 3, that is 1. Okay, so 1 mole of nitrogen is required, and that will give you 2 moles of ammonia. Similarly, we don't have 3 moles of hydrogen. How many moles we have? 7 moles we have. That means how much nitrogen we need now? Out of 7 moles, it is 7 by 3. That means it comes around 2.33 of N2. How much do we have here? 10. But we don't use all those 10 moles. We just use only 2.33 moles of N2, and that is enough. Okay, 2.33 moles of N2 with respect to 7 moles of hydrogen. And then how many moles of ammonia are possible? If you see very carefully, the relationship between the number of moles, it is important. Here 1 mole is giving 2 moles of ammonia. 3 moles of hydrogens are giving 2 moles of ammonia. So you can consider these two or these two, because 1 and 2, it is quite easy. This is 1 mole and this is double of that 1 mole. So whatever the number of moles of nitrogen you are getting, you can multiply that with 2 to get the respective ammonia. That means it will give you around 4.66 moles of ammonia. Simple. So that's how you have to check for the limiting reagent, and depending upon the limiting reagent, you can predict how much is your product available in that particular reaction. Okay. Now let's check on few more important concepts like percentage composition. What is this percentage composition? Okay. Let's assume there is a ride where only 2 or 3 people can be accommodated. That means you'll go with your friends, and only for 2 people that fellow will say, no, this is enough. We can't get other person there. Maybe someone is too fat or someone is too slim, depending upon that. Then when we need to take the percentage of those people, those 2 people, we can't say both of them are 50-50. It depends upon the mass of the person, right? So if that person is too slim, he or she can be below 50%. If they are very fat, they can be above 50%, right? Like that. So when I say carbon monoxide, let me take the example of carbon monoxide. So by looking at this carbon monoxide, most of you will think like, okay, carbon is 50%, I know, or oxygen is also 50%. No, that is wrong. So then how can we check that? So it is very simple. You have to take their atomic masses, which we have discussed in the last class, right? Okay. So the carbon's atomic mass is 12. So if I need to check for percentage composition of carbon, so how many carbons do we have here? Only 1. And the mass of carbon is 12 divided by the total mass of carbon monoxide. 12 from carbon, 16 from oxygen. So together it comes up to 28. Exactly, correct. Into, because we are checking for percentage, percent. Cent means 100. So that is 100, and we will get it up to. So it will come around 0.428. Okay. So this will gives 42.8%, not 50. Little less than 50. Correct? Okay. Similarly, let's check for oxygen. So how much we can have oxygen here? It's very simple. Percentage of oxygen. Please don't do all this again. It's very simple because we do have only 2 elements here. You can just do it like 100 minus, remove the percentage of coke or the carbon. That will come up to 57.2. 57.2% of your oxygen. So this is how you have to check for the percentage composition. Now you can also check for H2O, where it is coming up to 2 plus 16, 18. The mass of water is 18. So percentage of hydrogen can be, there are 2 hydrogens, 2 by 18 into 100. Give me the answer in comment. And percentage of O here is 16 by 18 into 100. Though the hydrogen is more in the water, it will not come up to 50%. Right? This is how we have to check for the percentage composition. For more detailed explanation, for more queries to be solved for one-on-one sessions, please comment or DM in Instagram so that you can have the classes from Crack the Complex. And please subscribe for more videos so that you will be getting to know, learn chemistry in easier ways. Thank you so much.